Welcome to all of you. In last lecture, we discussed about some of the quality parameters of petrol. I discussed about why there is a limitation on sulfur content, why there is a limitation on lead content in petrol. Now, in this video, we will continue the discussion. I will discuss about some other quality parameters of petrol. I will discuss about why there is a limitation on aromatics content, why there is a limitation on olefins content, and what is gum formation, what is oxidation stability of petrol. So let us start our discussion. So to understand basically why there is a limitation on olefin content, we need to understand what is oxidation stability of petrol and what is gum content or what is gum formation. So whenever I say stability of any fuels, it means that its resistance of any change. For example, if any fuel is having very good resistance of any change, then it is called it is having very good stability. And if fuel goes in different reaction very easily, so it is unstable. So even stability is of two types. The one is called storage stability, another is called thermal stability. Now storage stability is the ability of a fuel to remain stored for extended period of time without any appreciable deterioration under ambient condition. Okay, so if any fuel having very good storage stability, so you may store it for very extended period of time, and then also it will remain as if it is just manufactured. Okay, so there should be a good storage stability. Now thermal stability is basically ability of a fuel to suffer relatively high temperature stress for short period of time. So of course, if you keep petrol for at very high temperature, then it will go to different changes, different deterioration. But if you are just putting for very small time at very high temperature, and if it is resisting any change for that small time, then it is having very good thermal stability. Okay, so what happened, generally we manufacture gasoline from any refinery, and it ultimately go to marketing terminal where we further add some additives. Okay, and ultimately it may remain at marketing terminal tanks for very large amount of time, maybe 6 months or even larger. And even if we supply from marketing terminal to any petrol pump, it may be possible that it remain for large amount of time at petrol pump also. So whatever maybe during transportation or whatever may be reason, it may be possible that we are manufacturing gasoline today and it may be used in car for maybe after 1 year or 6 months. So there should be a good storage stability of petrol. Okay, but reality is in petrol there is a tendency of gum formation. What happened? Some component of gasoline basically react with atmospheric oxygen at ambient temperature and produces gum. Okay, so gum formation is basically linked with a storage stability of petrol. So we can say that gum formation is synonymous with the storage stability, or it can be also called as oxidation stability, because gum formation is basically reaction with atmospheric oxygen. So due to this gum formation, the storage stability of petrol reduces. So whenever I say gum, I refer a large kind of a species which is having a tendency to stick on any metal surface or any surface. Okay, so it is just like a gum. Okay, so during reaction, during storage, petrol goes to permanent deterioration such that it forms gum forming materials it forms, and because of that reason it has a tendency to stick. Some of the components, some of the residue of gasoline may stick on the different surfaces of petrol engine or carburetor. Okay, so here I have written gum is a general word referring to a large kind of a species, highly substituted aromatics in nature, and initially in gum forming period, initially it forms soluble gum which remains inside the petrol. and it may deposit during evaporation, or ultimately if it is stored for even larger period of time, then it may form insoluble gum which it may deposit at the tank itself. Okay. So early stage of gum formation is soluble in gasoline. It may appear as a sticky residue on evaporation. So if you evaporate the volatile component, it may appear. Otherwise, it will remain inside the petrol, soluble gum. But insoluble gum, it will deposit instantaneously. Okay. So let us discuss about how gum formation is deleterious for our car. So basically, gum is, as I discussed about, it is highly polymeric materials. It is aromatic in nature, substituted aromatic in nature, and because of that, whenever gum will form, the petrol density will increase. Okay, as well as distillation temperature will increase, because it is forming a heavier component of molecules which otherwise should not remain in petrol. So olefins content and diolefins content will reduce, because in petrol, olefins and diolefins are very reactive reagents. We know that paraffins are not reactive, because we know that's why it is paraffins, and the name itself suggests that it is having para affinity, means very less affinity to other molecules. But what happens in olefins and diolefins, there are pi bond which is loosely held with nucleus. We know that from basic chemistry, and because of that reason it goes to a large number of chemical reactions called electronic substitution reactions, electric substitution reaction. Okay. So because of that reason, olefins is having very good reactivity, and that's why olefins react with oxygen, atmospheric oxygen, even at room temperature, and may form gum. So that's why olefins concentration will reduces, and concentration of aromatics and oxygen increases when gum forms. Okay. So which component is responsible for gum formation? Olefins of petrol is responsible for gum formation. Anyway, now the product of gum, or ultimately what happens, it stick to the vehicle fuel system from the tank to the combustion chamber, and deposition in large quantity of gum in carburetor or combustion chamber or admission valves ultimately prevent good work of fuel lines, and ultimately it results to inappropriate air fuel mixture. So due to deficient fuel burn, again incomplete combustion will promote. Okay. So ultimately, if deposition increases at very high volume, so it may cause a starting problem, low gear problem, and ultimately it will necessitate cleaning of carburetors. Okay. And even in electronics injection car, it may plug the electronic injection, electronic injector. So the problem associated with gum content may be understood from this slide. Okay. So I am going to summarize here. So basically, gum deposition in injection system and combustion chamber affect drivability because of air combustion mixture will disturb, and it may cause engine choking. Engine performance also reduces, acceleration will reduce, it basically will increase the heavier component of or it will basically increase the distillation range at a higher limit. So because of that reason, it will also cause other problems, like as I discussed in the first part, the problem associated with the distillation range having boiling point more than 190 degrees Celsius. Anyway, ultimately, as I discussed about, whenever there is a solid deposition inside the combustion chamber, it may form hot spot, and ultimately it may cause detonation or pre-ignition. So octane number requirement will also increase. Ultimately, in exhaust gas emission, it may be the region of emission of carbon monoxide and other unburnt hydrocarbon because of this disturbance in air fuel mixtures. Okay. So let us now discuss how we will decide that how much gum is available inside the petrol. That is we are now basically the purpose of this discussion is to quantify the gum. Okay, now there are two different types of gum content. One is called existent gum and the another is called potential gum. Now existent gum is those type of gum which is remains even after manufacturing of petrol. Means if I have just manufactured today, then also there will be some gum component in petrol, and that is called existent gum, that is free form. So how we determine how much existent gum is there inside a petrol? So basically what we do is we evaporate the volatile component of gasoline. So the residue which left is basically maybe combination of existent gum and non-volatile oils or any additives if I have added. Okay, so what we do is existent gum is basically extracted by heptane. So what heptane does is heptane remove non-volatile oils or additives from the evaporation residue. So whatever the left will be existent gum. Okay, and there is a quality parameter, there is a restriction on existent gum, that is maximum amount as per BS4 standard is 40 gram per meter cube, and this will remain same as even in BS6. Okay, now potential gum is the potentiality of the material to form gum formation on long storage. Okay, so whenever we manufacture petrol, it should pass different quality parameters. So whether it will form gum in carburetor or car engine or not, we have to check right now, because I am going to sell my petrol. So one check will be on existent gum, how much gum is right now available, I have just manufactured. Another check is how much potential to form it gum during a storage. Okay, so how we will check? So we need to measure the potential gum of gasoline. So there are two methods. The one method is called induction period method, another is potential residue method. So in induction period method, what we do is we basically put our petrol in a bomb initially at lower temperature, maybe 15 to 25 degrees Celsius, with oxygen at 689 kilopascal, and we heat it up to 100 degrees Celsius. Now we know that instability is basically due to formation of peroxide or hydroperoxide, where oxygen is consumed and ultimately peroxide react with olefins. So what's if there is a potential of gum forming tendency, so what will happen? Petrol component will start reacting with oxygen. Okay, so due to that, oxygen pressure should reduce. So during this experiment, what we do is we keep noting down the pressure of oxygen at different intervals of time, and the time required for fall in pressure by 0.15 kg per centimeter square within 15 minutes is called as break point. So we are just mentioning the pressure reduction at different interval of time, and if within 15 minutes pressure reduction is 0.15 kg per centimeter square, then we call it is break point. Now basically we measure the time required for sample to reach this break point. So let's say initially it is the pressure reduction of oxygen was only 0.05 kg per centimeter square in 15 minutes, but after 1 hour it is finding that oxygen pressure is reducing 0.15 kg per centimeter square within next 15 minutes. It means my induction period is 1 hour. Okay, so we just measure the time required for the sample to reach this break point. Okay, now if induction period is high, it means that the potential gum forming of petrol is very less. It means that gasoline is stable, very less chance of gum formation. But if induction period is less, it means that gum forming tendency is very high. So that's why there is a limitation on oxidation stability in Europe BS4 quality parameter, and that is written is the minimum induction period should be 360 minutes. Okay, so if it is lesser than this 360, your petrol will not qualified for selling. Okay, so there is a limitation on this. In potential residue method, what we do is we measure the amount of soluble or insoluble gum after which ultimately precipitate, and we measure simple measurement of the weight. Okay. So we now further know another quality parameter about oxidation stability and why it is so. Okay. So finally, let us discuss about how gum formation take place. So basically, we will discuss about the mechanism. We will discuss it very briefly. So basically, gum formation is a result of chain reaction initiated by a free radical, okay, such as peroxide, and it is catalyzed by the presence of metals, particularly copper. So it is a free radicals reaction where peroxide react with ultimately olefins, and the reaction is catalyzed by the metal catalyst such as copper. So the degree of unsaturated like olefins, particularly diolefins, as well as sulphur in the product is the controlling factor of gum formation. So if more diolefins is there, sulphur may also contribute, then gum formation will be high. So how it take place? Ultimately, basically what happens, any olefins may break into one free radicals R dot or H dash, and these free radicals ultimately react with oxygen, forms peroxide ion, and this peroxide ion may further react with another olefins, and it may form a large free radicals, and it may further react with olefins, and in that way it may polymerize. Okay, so this is the reaction mechanism. Now if one peroxide ion react with another peroxide ion, this chain break. It may also react with another hydrocarbon free radicals, then this reaction may break, and if two peroxide ion may react combine, then also this reaction will terminate. So these three are termination steps. Okay. Now as I discussed that olefins having very high tendency reactivity because of this loosely held pi bond, and because of that reason olefins is also having tendency to form ozone if olefin is going into the atmosphere. So that's why because of all these reasons there is a limitation on olefin content, and the maximum allowable limit is 21% in regular grade petrol and 18% in premium grade petrol. In BS6 the quantity will remain more or less, it will remain same. Okay. Now the same mechanism is given here. This olefin may form these free radicals which are combined with oxygen and forms peroxide free radicals. Ultimately these peroxide free radicals may react with different olefins, and ultimately this may polymerize to gum, and these are the termination reaction. Okay. Now there are some additives to improve oxidation stability which we usually add with petrol, and the one is called antioxidant. Antioxidant basically are alkyl phenols. Basically what it does is it reacts with peroxide radicals, and in that way it breaks the chain reaction. Okay. There is another additive called metal deactivators. Basically we know that copper can catalyze this gum formation reaction, and that's why what happens, metal deactivators basically inhibit this copper to prevent this action. Okay. Apart from that, in petrol we add multifunctional additives basically to ensure the proper cleaning of the fuel system and intake system of any engine. And there is another limitation on BS4 quality parameter of petrol, that is engine intake system cleanness. Basically you have to report that whether you have used multifunctional additives or not, and that multifunctional additive should be having a credential from different testing agency, that it should be certified multifunction additives. Okay. IOCL which basically sell superior gasoline, extra premium gasoline, basically contains very good amount of multifunctional additives which ensure the cleanliness of the intake system. Okay. So that's all about olefin contents and oxidation stability. Now let us discuss about the limitation on aromatics content. Now there is a limitation on aromatic contents. Right now in BS4 there is a limitation on 35% volume. Maximum allowable limit is 35% volume. In BS3 it was 42%, but we have reduced right now to 35%. And benzene content is having restriction of only 1 volume percent. Now by these restriction, the restriction on benzene content is because it is carcinogenic in nature, so it may cause cancer in human, so that's why there is a restriction. Now in aromatics, some of the aromatics are also carcinogenic in nature, but not as such as benzene. That's why there is a separate restriction on benzene content. Aromatics, in aromatics content, basically we know that as I discussed in last lecture, that whenever hydrogen by carbon ratio in any hydrocarbon reduces, then the chances of incomplete combustion increases, and we know that carbon hydrogen ratio of aromatics is very high. I mean, hydrogen by carbon ratio is very less. That's why it basically forms a sootier flame. An incomplete combustion or unburnt hydrocarbon in exhaust stream is basically due to aromatics content, and that's why there is a limitation on aromatic contents because of two reasons. Unburnt hydrocarbon will increase if aromatics is high. Another is it is carcinogenic in nature, so that's why there is limitation. Apart from that, there is another limitation on copper strip corrosion, because we know that there may be some copper alloy fittings in engine and some other connection, and so the petrol should be such that it should not corrode the copper fittings. So we test by copper strip corrosion. So what we do is we put copper for let's say 3 hours at 50 degrees Celsius, and we check the copper strip corrosion, and we match with the standard copper strip corrosion, and if it is and we put in different class. So if very small or almost nil corrosion, then we call as class 1 corrosion. If it is larger corrosion then or higher corrosion, then class 2, even higher 3, or class 4, very high corrosive, then 4. So there is a limitation that it should be not more than 1A or 1B, that's all. If it is more than 1, it means it is corrosive to copper, and that petrol will not be sellable in market. So anyway, I am going to stop this discussion right now. In next part I will discuss about the oxygenate content limitation, and that part that will be the last lecture on motor spirit quality parameters. Hope you are enjoying these lectures. Thank you for watching.